and today we are talking about decision controls. So let me write it here. Say it's called decision control, right? Earlier we did sequential control. In decision control, if you remember the flow chart, right? In the flow chart, I mean, today we executed one statement. We took some input in general. We executed one line, we executed second line, we executed third line, we executed fourth line, and we closed. This is start, right? And this is close. So this is the algorithm we followed. Everything is a rectangle. I don't draw a good rectangle. And every line of code executed in sequence. We did not skip any line of code. But in decision control, under decision control, we are going to learn how to skip some based on certain decisions or condition. And if you remember, there is a flowchart that is of shape diamond, and diamond is for decisions. If some conditions here, right, if it is condition is yes, then you go this route, otherwise you go this route and say yes or true or no or false, right? No or false. Then you want to do something. If the condition is different, then you want to do something else, and then you may continue and converge, and then you have some common code. But this line of code or this line of code depends on true or false, and that is what we will learn in next few lessons. At least 3-4 lessons, I'll talk and teach you different type, how to create decision, how to form a decision, how to implement your decision in your program, how to draw flowcharts and then convert that flowchart into code, or how do you read a code and create and understand the logic. Suppose somebody has written this code which involves some sort of decision. How do you read that code and understand what decision they are making it? So this will require your analytical skills. This will require you to understand and that there is a condition in this program, and if there is a condition, how do I take this condition? How do you join two different conditions? Those type of things. It's pretty fun stuff actually, and it will you will, I'm sure you will like it. It's a pretty interesting actually. Okay, so before we learned about decision making, what we need to do is to identify that a code has a decision, right? When I say code has a decision, suppose you go today for vaccination, right? And you are less than 12 years. You are less than 12 years. So the vaccination center is going to say, sorry, this is not for you. But if you go and if you are more than 12 or more, in that case, vaccination center will accept you. They will vaccinate you, and then you come home. So the way it will look like is, suppose I draw a flow chart of this decision control, right? Let's say we'll say start. Okay, I'm gonna pick blue color now. Start, and then I'll say, start, and then I say, I'll ask your name. Say name, read name, right? Read name. So you are assuming that you are at the gate, and this computer program fed into a robot is going to ask your name. Once you ask your name as an input, then I'll say, okay, do some processing. I'll say hello, some name, right? I put hello under single quote because it's a fixed string, but name is a variable. Then next thing you want to do is to check, and we'll say, my bad. Second thing, I will, before I even enter your name, what did I do? Okay, name, right? I will also ask, what's your age? And say read age. Whatever age, I'm going to ask you a message saying enter your age. You enter the age, I'll convert into a number because I'm going to do some operation and ask your age. Next thing I want to choose, check if that's a diamond shape, and say if age is greater than or equal to 12, and answer is yes or answer is no. If answer is no, then you want to say sorry, your name, something, and say answer is yes, and then I'll say welcome, whatever name. The next thing I want to say is vaccinate, and then I'll say finally and And assuming that if I say sorry, then again I will also end here. Correct? But ultimately, the algorithm has to start and end. That is how you define the make it finite, countable number of steps and all. We already know that. So this is how you draw a simple vaccination program that says based on your age, I want to give you vaccine or not. Right? As you can see here, that this part in green is what is controlling whether it will go this route or it will go this route. At any point of time, sorry or welcome will not be these two steps or this step. Only one of these two will print for everybody, because you cannot be greater than 12 and also less than 12. That's not possible. So either you will execute this line of code or you will execute this line of code. However, you're going to write 3 lines of code, but you are going to do branching. It's like you're driving a car and you're on a stop and it's a dead end. Either you go left or right. You cannot go left and right together. Similarly, here you have to either go yes or go no. So when you write code for this type of problem statement, this one what I gave you is a very simple one. You may have multiple conditions. You may have multiple scenarios. If you do this, then also check this condition and all that part. And you will have a lot of practice on that. But then bottom line is ability to identify that this program has some conditions. Number 2, create the condition. And number 3, identify the branching. Should I go this route? What will happen? Should I go this route? What will happen is what we are going to learn in this class and in the subsequent classes.